All right, mathematicians, today we are going to keep building off of what we've been looking and learning about with different types of angle relationships. Today focused primarily on using what we discovered with triangles always equaling 180 degrees for their interior angles. Remember, you can either print this page out and complete it on paper, or you can use Notability to complete it as you are going along. If you remember from the other day, we discovered that a triangle is always going to have 180 degrees as the sum of its interior angles, and that is because it is one triangle. And then now what we're going to do is we're going to use that idea of triangles to try and split up some of our other figures to determine how many degrees are on that figure based on the number of triangles that there are. A couple of rules as you're doing this is that when we're creating triangles, a really common thing that I'll see people do is they'll do something like this and they'll say, oh, there's 4 triangles. But there isn't actually 4 triangles because of this right here. Those lines crossing create angles that aren't in a corner. So when we are creating our triangles, we can only create triangles using lines when all of the angles are accounted for in one of our corners. The way I like to think about it is I'm going to choose one vertex. So say I'm going to pick this corner, and I'm going to draw lines to every other vertex in our shape. So I have a line here, a line here, and a line here. So since I've touched every other vertex, I can now see that when I have a 4-sided figure, I end up with 2 triangles. And since each triangle, no matter what the individual angles are, always adds up to 180 degrees, the sum of our interior angles is going to be the sum of 2 triangles. So in other words, it's going to be 180 2 times, or 360 degrees. Let's look at our next example. So now we have this pentagon, which is a 5-sided figure. Once again, I'm going to choose one vertex. This time I'm going to use the top. I'm just going to go to each other vertex. And I can see now I have 3 triangles, which means the sum of my angles is going to be 180 times 3, or 540 degrees in a pentagon. Now I would encourage you to pause the video and see if you can do the hexagon, heptagon, octagon, nonagon, and decagon by yourself, and then start to think about, is there a pattern that you are noticing? And then I'll kind of just go through and draw in the shapes and you can kind of check. All right, so here we have our 6, 7, 8, 9, and 10-sided shapes. I'm going to draw in my triangles. As you're doing this, because we've talked about math being the study of patterns, I'm hoping that you are starting to see a pattern and you don't actually have to draw in all of your triangles. So like for example here, our 6-sided figure, we end up with 4 triangles. Our 7-sided is 5, our 8-sided is 6, our 9-sided is 7. So if we follow that pattern, we can predict that with the 10-sided figure, there's going to be 8 triangles. If you don't believe me, you could still draw them all in. Obviously, they're going to keep getting smaller as you go. And you'll also notice that the more sides the shape gets, or the polygon gets, the closer it gets to looking like a circle. Right, so as we're doing this, each of these, or you could just add 180 each time, so this becomes 180 times 4 or 720 degrees. And I'm just going to keep adding 180 because it adds a triangle every time. So this one becomes 900. Hopefully here you got 1080 degrees. For a 9-sided figure, for a nonagon, we have 1260 degrees. And then for a decagon, it would actually have 1440 degrees. So this is great, but obviously you don't want to have to draw out your shapes every single time. And if you've been looking at the pattern, hopefully you started to notice that when you have an n-sided shape that creates, or like an n-gon, right? So it's going to have n number of sides, that the number of triangles, as we look here, if we look this way at the relationship, the number of triangles is always 2 less than the number of sides. So it's going to be our number of sides minus 2. And since each triangle is 180 degrees, we can actually find any shape by taking 180 times the number of sides minus 2, and that would give us how many degrees are in a polygon. I know that there are some examples down here, but some of them are like the ones on the top. So what I'm going to do is I'm actually going to give you an example of what's called a 50gon. So a 50gon is just a 50-sided figure. So to figure out how many degrees would be in a 50gon, first thing I'm going to do is I'm going to take 50 minus 2 to determine the number of triangles, which would be 48. And now I'm going to take 180 times 48, and that equals 8,640 degrees inside of a 50-sided shape. If you want, you can definitely do the practice ones on the bottom. The completed notes will have the answers for all of these. If you want, so the rule is basically what we did up here. It's just that you're always going to take 180 times the number of sides minus 2, and then you can go through. So this would be 360 degrees, 540. Those are the first 3 are from up on the table. 1080, and then this would become 1620 degrees and 2340 for a 15-sided figure. Let me know if you have any questions, post them in the comments, or you can send me an email, fill out the Google form, and then I can get back to you about any of the questions that you might have.